All right, guys. Hello and welcome. I'm a software engineer and consultant. My name is Sirar Salih, and I work for Itera, Norway. How's the voice? Is it good? Yeah? Is it right? All right, great. No? Too low or? Okay. I guess I'll just have to speak closer to the microphone. Okay, guys. So today we're going to talk about AngularJS and TypeScript. How many of you have worked with Angular? Oh, cool. That's awesome. And how many of you have worked with TypeScript? Fewer, but still cool. And how about a combination of both? Even fewer. Okay, cool. So this is awesome. As I said, I come from Norway, so this is where I live. This is Oslo, Norway. Now, this is how Oslo looks like on a typical Tuesday afternoon. Pretty nationalistic country. No, I'm just kidding. This is actually from last Saturday. It was Independence Day, and it was actually a special day because it was anniversary, 200 years. So the country is 200 years old, and it's the most expensive country in the world. One glass of beer, half a liter, it's the same as 10 half-liter beer in the Czech Republic. Similarly, 1 cup of coffee from Starbucks in Oslo is the same as 2 cups of coffee here in San Francisco. And I thought that San Francisco was expensive. Okay, so moving on. Basically, I've worked with C++. That's how I got into programming. I started first with 2D games and algorithms and things like this. Pretty proud of a Pac-Man game that I made many years ago, like a multiplayer Pac-Man, which was quite fun. But after that, I moved on to the .NET stack, so worked with .NET development, basically with desktop apps and web apps. Yeah, so that's where I am today. But then I moved on to the HTML5 JavaScript world, and then it's just been a loop there, just around and around. And I have to say that it's really, really interesting to work with the web and front end. All right, so that's typically sums it up about me. State machine diagram is always nice. Okay, so we're here to talk mainly about this awesome JavaScript framework, AngularJS. Now, I saw that a lot of you have worked with Angular. So what I'm going to do is I'm going to just try to go fast through the slides of the introduction to Angular, because I understand that you already know it. So basically, but what I love about Angular is basically what happens here. The beautiful thing here is that with Angular, you get to minimize the server bottleneck. So you can use the client much more. Let's say, for instance, if you do a get once and retrieve all data, and then I like to picture Angular as a ladder, as you see there, as an angular ladder. So basically, you get the data, and then you have all the data on client side, and you can do whatever with the data, and then you could do your post later. And that really increases the efficiency, and it makes for a really nice user experience. Yes, so basically, before we get to this part of combining two forces, the AngularJS and TypeScript, I want to just go through the things that are really awesome with Angular. Basically, directives. Directives are really the future of HTML. Creating your own custom elements in HTML is something really beautiful. This is what we got with HTML5, and this is where the future is heading for HTML. And as you know already, you got the data binding, controllers where you put your behavior, your logic, and so on. And validation is nice, localization, filtering, everything is awesome with Angular, at least with my opinion. So, but the main thing that really motivates me working with Angular is really the testability aspect. Now, Angular was designed from the bottom up to be testable. So this is really cool because it makes dependency injection easy, and it makes TDD an easy thing to do, right? So this is really the motivational factor. Other than that, probably I would use another framework. I'll have to be honest with you. But since I'm a test evangelist and I really love the TDD aspect, I really love Angular. So you're basically already familiar with this. You have modules that you bind in the HTML. And you declare modules with some dependencies. It's nice having some submodules or subdependencies like controllers and services declared as a dependency to the main module. And declaring a controller like so, and so on. You have your logic in there, and you have your HTML at the bottom here. We have an ng controller binding to a student controller, and so on. So this should be familiar. And the same way we have a directive here having a template, pointing to templates. Now, directives are really great. They're really magical, in my opinion. A directive has like up to 12 different properties. Did you know about this? You can do so many things with directives. It's insane. Probably, at least from my experience, I've used probably up to 4 or 5 properties at once. So I've never used all 12 properties. That's insane. But you can do that. You have, for example, in this example here, we have restrict, which, as you know, is restricting a directive to be an element, an attribute, a class, or a comment. A scope, you isolate. You have scope isolation for directives. So let's say if you have a directive inside a controller, you could isolate the scope of the directive by defining the scope here. Setting it to true would do, or you could use the equals, as I've done here. And then I would say here I've set it student and then equals. Then you would do in the HTML student equals student. And also you have, notably you have the linker or link, the link property, which is nice if you use jQuery with Angular, which you shouldn't do, because this is really, this is not the way to do it. I mean, we use Angular to avoid jQuery. But there are sometimes you have like, let's say you're working with legacy code and you really can't avoid jQuery, right? So you have this link property here, which you could use, and then you could bind events on the link property. All right. And then we have like factory and service. Factory, in this case here in this example, I have basically a factory, a HTTP factory, which defines a get and a post, which is like having a backend as well. So it's binded with the backend. So in this case, I'm just saying, okay, I have a getStudents function, which is pointing to a get, a student controller, yes, in the backend, and the same with the post. So this is a very simple service. All right, and probably your backend would look like this. Now, when you work with AngularJS, you don't really need a backend. All you need is a service, like let's say WCF or anything that you use, and then you could use Angular on top of it. You don't really need a backend with it, but in this case, this is just an example to show you that, of course, you can if you want. All right, so basically, this is like Angular in a crash course, since you guys are already familiar with Angular. So we move on to this guy here. Do you know who this guy is? This is Anders Hellsberg. Anders Hellsberg has worked for 15 years at Microsoft. Now, Anders woke up one day and just decided to create a typed script language that made it possible to write object-oriented JavaScript, typified JavaScript. Now, what his motivations were, I don't know, I will not know, but probably I would guess because he works at Microsoft, he's a .NET developer. Probably he thought that .NET developers are they'd like to avoid JavaScript. I say this because I am a .NET developer, originally. So he said, okay, how about I create a language, TypeScript, typified script language that makes it easier for .NET developers and makes it maybe their life easier. So TypeScript was founded by this guy. And TypeScript is very similar to C# in many ways. And Java, Java is really similar to C#. They're C# is based on Java in essence. So he created TypeScript. And TypeScript, have you guys worked with CoffeeScript? Yeah, so it's similar to CoffeeScript, but probably it's even similar to C#. So, but don't get confused that TypeScript is open source. So it's not a Microsoft-only language. It's open source. You can use it anywhere you want. You can download it. The code is open. So it's a JavaScript compiled language. And yes, you have object orientation. You have classes, everything you want, interfaces, base classes, inheritance, namespaces, which are really nice. How many of you are .NET developers here? Are there any .NET developers? Okay. All right. So yes, namespace should be like familiar to you, I guess. But it's basically like modules or path, like a path in the code. I'll show you later. All right. So I just thought that I'd show you some examples of TypeScript. Now here's an example. Here we have a class human, basically that has a method get eye color, and we have an interface iPerson. And class person extends human, so we have inheritance here, and implements the interface iPerson. So this is simply object orientation here in TypeScript. Now when I write this code, at the same time when I'm writing it, it gets compiled to JavaScript. You see, so this will be compiled to JavaScript. So you write it, it looks like this. It looks like a pure typed language, static language, right? But what you get is this mess here, this horrible mess. So this is the compiled code, what you see here. This is the compiled JavaScript code of the slide, of the previous slide. This is the slide here that gets compiled into this slide. So this is how it looks like. Now basically, this is how it looks like in production. Like when what you do is you work as a TypeScript developer, you write in TypeScript classes, TS classes. You check in, and you make the build server compile this into JavaScript, and then push it to production. So this is how it looks in production. And of course, you're gonna minify it, minification. You're gonna use that as well, so it's gonna look really horrible, but that's how it looks like. So you're probably wondering, hey, how the hell am I gonna work with this, right? Like I work with JavaScript, how am I gonna work with this? Well, the answer is you don't really care about this because you're working with TypeScript code. You're not working with JavaScript code. All right, so other cool things here is that we have these modules in TypeScript. Now don't confuse module in TypeScript with module in AngularJS. It's different, it's a different thing. So modules are like namespaces, as I mentioned earlier. They're like, let's say you're making some lasagna, right? And you have some layers. So modules are like these layers in the lasagna. So you wanna put a layer at the bottom, in the middle, and so on. So this is what you do with modules. In this case here, we just extracted the class from the 2 slides ago and just put it in a module called races. And then what we do here is we share the races module across different files, so that other classes can use this module. So at the bottom here, you'll see that we have a reference path equals races.ts. Now, when I do this, I get all the stuff from the races.ts file. I get access to the class inside it. Now, when I do this, I have to use the keyword export in front of class. So the class gets available outside the module. All right. And of course, you have internal modules as well. And this is how it's done. You just use the import keyword, import. In this case, ethnicities, module ethnicities. And in the class, we simply, once we create an object, we return a new, and we just use the module as usual. So we have internal modules as well. All right. So we take both of those, we combine them. And when we do that, we get a great power. Now, with great power comes a great responsibility. This is what we learned from Uncle Ben. So with all this great power, we have to tame the responsibility, right? And we'll get to that. First, I want to show you how you do this. Now, you won't meet a lot of people who have combined AngularJS and TypeScript. You won't find so many people. So basically, if you want to do it, you have to follow this guide here that I'm going to show you. And of course, I'll put the slides up and you'll see it. I'll put it on GitHub also if you're interested. All right, so you start with the Bootstrapper. This is the first thing you start with. And here you wire up your dependencies and everything. Now you're used to already to wire up your AngularJS components, right? So what we do here, we use both. And we use Lambda expressions. You get Lambda expressions with TypeScript, and that's pretty cool. So a Lambda expression is basically a function. It's function and function parenthesis. That's the same as a Lambda. And basically what we say in this case, we have a my app module, my app.controller define the controller and its dependencies, scope, main service, which is a custom service in this case. And then we use Lambda, and we say, hey, return a new app.mainFeature.mainController. Now, app.mainFeature, this path here is basically a module. So I've used a module app, and then I've used a module main feature. And inside these two, I put my main controller. And I just say, hey, I just say this to Angular. I say, hey, create the controller and return to me a object, a main controller class object, instead of how we do it usually with Angular. We do the same thing with the factory and with directive. All right, so when you use TypeScript with Angular, all you have to think of is just classes. You have to think about object orientation. So we have, here is how my main feature class looks, my main controller class looks like. Basically, we have a scope, and we have the main service, our dependencies at the top, and we have the constructor. And this should look familiar to you if you work with backend code like C# or Java, where we have dependency injection. Right? So this is what's happening here. We have a constructor, which takes in a scope, a main service. And these two are injected into the constructor. Right? So you see the DI here going on. And then we simply have a method here, getMessage. All right. So in the HTML, when you use TypeScript with Angular, you have to use Alias. Now, we use Alias like so. We say ng controller, main controller as MC. And in this case, I'm saying, hey, when I click on a button, just fire up the getMessage method from my main controller. So as you see here, getMessage is an exposed method from the main controller class. It's a public method. We also have scope here. We have private scope and public scope. Now, this is definitely not something you're used to if you work with JavaScript and Angular. But here we have private and public in TypeScript. So, and then basically we say, hey, once I click this message, please update, once I click this button, please update the message property, which is in the main controller, mc.message. And the same way, we do the same thing with directives. We have a main directive, and it looks like this. It basically says, hey, return the template, return the directive itself. So that's how it looks like. It's a class, and I say, in the constructor, I say, hey, return getDirective method. Inside the method, I have defined my directive here, as you can see. So inside this return thing, in the getDirective method, I have these properties of the directive. So simply return this, and it will understand that, OK, this is a directive in its own. I hope that you're following so far. That's awesome to see. So what's probably a little bit weird in this case is I'm using a return in a constructor. Isn't that weird? Yeah, but that's how it works. So this is how you should do it when you create directive classes. All right, now the fun will start. So what we're going to do, we're going to test drive AngularJS and TypeScript. We're going to run TDD. Now, how many of you test your JavaScript here? Yeah, it's not full house, you could say, but I see some of you doing it, and that's nice. Testing is really important, and TDD is something that I advise, and it's the best practice these days. So I really go for it and do TDD. Now, in this picture here, you see three things. The first picture is a flower, a Jasmine flower. So this is basically the Jasmine testing framework. And then we have something called Karma. Are you familiar with Karma? Yes, that's great. So Karma is basically a test runner for JavaScript. And Karma is really nice to use with AngularJS. It's actually recommended by the creators, the founders of AngularJS, to use Karma. So Karma is an awesome test runner that you should use. Now, use this with Jasmine, and then finally, we have the final thing here, which is this is a city, picture of a city. Can you guess which city that is? Yes, that's correct. And what does that mean? That is correct. So he answered, it's a code coverage plugin. So we have a plugin called Istanbul plugin, which is a code coverage plugin, which is now actually integrated into Karma. So when you go into Node and type npm install karma-coverage, you'll actually get the Istanbul, which is now integrated into Karma. So I always recommend that you use Karma and the Karma coverage tool as well. So I'm going to run a live demo afterwards during the presentation. So I'll show you how this works out. All right. So let's now take an example. Here is an example of a test written in Jasmine. Now, this test here is divided into 3 parts. Now, the red part here, you have this area. Now, this is basically the setup of the test. Okay? So in this setup part, I basically declare my mocks and my dependencies, and I just say that, hey, before each test, I want you to load up my module and inject my dependencies. So inject root scope, main service, which is in this case my dependencies. So this is the setup area of the test. And then the test will actually start in the blue area. Now it says in this case, it should call main service.getMessage when main controller is loaded. So basically, spy on this getMessage method inside the main controller class and create the class, and please assert or expect that this getMessage is fired up, right? We're going to do a live demo of this, so you'll see this in more detail. All right, now the Karma test runner. The Karma test runner, you can run this from command line, or I'm going to use in this demo JetBrains WebStorm, which I really recommend. This is a great IDE, and it's, in my opinion, it's the best front-end IDE that I'd recommend. Of course, it's arguable, so don't shoot me for that. But it's Karma there are plugins for WebStorm, so you won't need to fire up a command line to run the Karma test runner and then write your code, and you have like 100 windows, right? But in WebStorm, everything is integrated. So you get Istanbul, you get TypeScript, you get Karma test runner, and Jasmine and everything. So you got all of your environment up and going. All you need is a Node, really, Node npm, and everything is fixed for you. So basically, in this case, we have Karma test runner running through a command line. And here I'm running a test. The first time, when you write TDD, you should go through the red-green refactor cycle, right? So the first thing I'm doing here, I'm writing the test, and it's red, because there's no logic for it. So I go in, I type the logic. The test is ran automatically, because you have auto running, and the test will become green. And then I can go back to my code, to my logic, and refactor the code. Now, this is probably familiar to you when you work with backend. Now, testing in JavaScript is something that is like, it's increasing now, recently, but it's not like, it's still a new thing. So, but this is how it's done. The same way as we do it for the backend, we do it in JavaScript. And here's the cool thing. With the Karma coverage, which is Istanbul plugin, you get an overview of all of your classes and the coverage, the test coverage of each class. Now, green means that there is a high coverage of your classes. So that's really awesome. Yellow is like in the middle, and red is like, whoa, this is critical, you have to for this class. Now, don't get me wrong. I'm not saying that you should have high code coverage for code. It's just that you should do TDD, because TDD will increase the coverage, right, automatically. But the point here is not to increase the coverage of the code. You should just have more tests, because it's really silly if you want to go, if you want to cover your code coverage, if you want to go from 80% to 100, that's really silly. Like 80 or 85% should be enough, because let's say you have some properties, like basic auto properties, getters and setters, right? You don't want to cover those. That's really silly, right? You don't want to have code coverage on those. They work out of the box. They're already tested by the creators of the language. So if you're working, like, let's say, for a customer, and the customer, this is actually has happened before. The customer says, you tell him as an architect or a developer, you tell him, hey, I've got 85%. I can get you 85% code coverage. The customer is like, no, I want 100%. I want 100%. I don't want anything else. 100. This is really silly. Like, you should really try to convince your project manager to tell the customer that no, this is really a waste of time. It's a waste of time to increase code coverage to 100%. So always keep at 80, 85. 85 is like really, really nice. And of course, if you click in this Istanbul plugin, which creates a HTML page for you, really, that's what you saw on the previous slide. If you click on each class, you'll see the lines like in the code, like so. So if something is not covered, it's red, like in this example. So I have some red here. That's basically the plugin telling me, hey, this code line is not covered by tests. This is not covered. This is not covered. So you need to cover it. In this case here, and this is an actual case from production, this slide here, you see like 2, 4, 6 lines are red here. Now, I don't know if you see it, but can you guess why they are red? I'm not going to blame you if not, because it's kind of hard, because this is JavaScript compiled from TypeScript. So it's not really human friendly. But can you guess why those lines are red? Basically, they're red because these are anonymous function calls in JavaScript. Now, anonymous function calls are not testable. You cannot test them. You can try to work around them, but you can't really cover them. You can like stub the dependencies, stub it out, try to have some wrapper around it, but in the end, it's not really possible to test anonymous function calls. So my advice is to try to stay away from anonymous function calls. Like, yeah, try not to write anonymous function calls because they make your life hard when you test. Okay, so always when you're as a JavaScript developer, always have it in the back of your head that testing is important, and always try to write code that is testable. If you write TDD, the code is testable automatically, right? So it's not an issue as long as you have TDD. I hope that I'm inspiring you through this to make you write unit tests and go the TDD way. Yeah, okay, so I'm thinking now that I'll go to a live demo, if that's okay for you. So, all right, so this is WebStorm, JetBrains WebStorm. It's getting pretty late in the day. So what I'm going to do is basically, firstly, I want to show you this part here. Now, how many of you are familiar with the feature pattern, the feature design pattern for AngularJS? Okay, that's surprising. So the feature pattern is the pattern that I recommend, and it's the best practice. Always use the feature pattern. Now, the feature pattern looks like this. You have a file structure that looks like this, basically. You have the Bootstrap. Now, in the Bootstrap, you create... Oh, now that is really weird. Okay, you know, this actually happens way too often. There you go. Sorry about that. So here I am in JetBrains WebStorm. Now, on the left side, here is how my structure looks like in this project. Basically, you create a Bootstrap. Now, in the Bootstrap, you put your wirings, right? This is what I showed you in the slides. Here you define basically how your controllers, your factories, your directives, and so on. You could divide this, if you feel like it, you could divide this file eventually, but usually you'd have one Bootstrap file. So, and then you create a folder for each feature. Now, in this case, we have just one feature, and that's called main feature. Now, for each feature, we create a folder, and we put our controllers, our directives, our services in that folder. This is the feature pattern. Okay, so what we're going to do is we're going to create a simple Hello World app with TDD. TypeScript, AngularJS, Jasmine, Karma, Istanbul, the whole package. So basically, what I've done before this talk is I just created the shell, okay? The shell of everything. So here's my service. It looks like this. basically I have an interface, main service, and main service implements main service, and it's empty, right? There's nothing happening here. And the same thing with a controller. It looks like this. All I have here is the default injection, which is scope and this main service. And I just set them in the constructor. There's nothing happening here at all. This is just the shell. So let's go to our test. Now our test is empty right now, right? So I know we've had a long day, so I'm not going to type each line. So here you go. Basically, we have our setup here. We have our root scope mock, main service mock, the main controller, which is the actual object. And OK, inject my app module and inject my dependencies, this line here. And here's a test, which I've already made. So again, this is the test from the slide. Basically, listen on a method on the main service and expect this method to have been called. OK, so what we're going to do is we're going to run karma with coverage. And there we go. OK, so it's red, right? The getMessage method does not exist. And that's true. So, and what you want to do is you want to have auto test running on. So auto test is really nice because it's going to run the test all the time. You don't need to save each time to have the test running. It's going to run all the time. This may get annoying or frustrating for you, but you can always toggle it. But it's nice. I think it's nice. So we get continuous testing here. OK, so basically, so the getMessage method does not exist. OK, let's fix that. So we go to the main service. We're going to create a getMessage method, which is a string. Now, this may look a bit weird for you, but this is how TypeScript works. Now, as I see, it's a bit slow because it's running all the time. So, but we're getting compilation here, compilation errors, and that's pretty cool. That's pretty cool. So, this is going to be public. And it's going to, at the start, it's going to return an empty string. That's what we're going to start with. OK. There we go. So now it's saying, hey, expected by getMessage to have been called. So yeah, so now we've made the service, but we're not using the service yet. OK? So this is cool because the test already knows now, understands that, OK, you've created your getMessage. I found it. But hey, it's not being called yet. Right? So we go to the controller. We create a property message. And a local method called setMessage. We have to use this all the time, which is quite annoying. I hope they're going to fix that with later versions of TypeScript, because it should be obvious that I'm using local stuff, local methods. And let's see. So like this. All right. So now we're using the getMessage. And it's a little bit slow here. There we go. So the test is green now. Awesome. All right. So what I'm going to do now is I'm going to create a test. Hello world. Okay. Here we go. So I'm just going to copy this. And now I'm creating the object, and I'm just saying here, please expect the message property to equal hello world. So now you can guess what's going to happen. Now we're going to have a red test, right? Expected undefined to equal hello world. Sorry, I think actually I should use this object here instead. And we should have instead main controller to message. Let's see here. Okay, so basically it's saying, hey, message is undefined. All right, so now we need to go to the service and implement our logic. So we'll say here, hello world, and hope that this is going to work. No, or oh, it's kind of slow. I think, let's see here. Oh, yes. We should have a return type. That's one thing. Really interesting when when things don't work on a demo, but they work on the day before. So this is weird. Yeah. Sorry? So message is string, and yes, that is true. You are absolutely right. As I said, it's been a really long day. So all we have to do is do like this. You agree? Because now we're just saying, hey, fire up the set message, and this message will be set by the get message. So of course, a void is a void. It's nothing. So let's see what's happening now. I think it's kind of slow. Let's just run it again. Ah, there we go. It's green. Thank you very much. Beer's on me. OK, so this is what we've done here. Now let's go. The last thing in the demo we're going to do is let's go to index. And in the index, I'm just going to say, hey, ng controller equals main controller as MC, mc.message, and we should be good to go, right? All right, here we go. Cool. So let's go back to our slides here. OK, that's strange. I'm using this this app on my phone. I was trying to let's see, I'm controlling the slides from my phone. And it seems that it's not always a good idea. OK, so let's just go through fast. OK. All right, so the last thing I want to do now is just go through some steps that you can do to automate this whole thing with TeamCity, for example. Now, if you work with .NET, you probably use TeamCity, right, as a continuous integration tool. If you work with Java, you'd probably use Jenkins or similar tools. Now, what you want to do is get test automation here. So actually, we still have some time, so I don't need to stress yet. So basically, what you want to do is you create some build steps that are going to compile your TypeScript into JavaScript, and then it's going to run up Karma on the build server. So Karma will run, and then you'd get code coverage from the Karma coverage tool, which you have put on TeamCity also. Now I'm going to show you how you do this basically. So here is just here is just a simple build step. Here. So when you go and click on build step, it's going to come up with this page here, right? So that's fine. What's important here is the second line, which I have here. Now this is what I call the magic code, or this is the magic code snippet. So basically, this does everything for you. It's in my case, in our .NET project system, what we're doing here is we're using MS Build, right? We use MS Build to build everything. So we just say, hey, use MS Build to deploy on build, set that, and put configuration to release, and put this as a command line parameter, right? As we have done here in the build step. That's all you have to do. And then you just have a path to the project name, and it'll do everything. This takes care of compiling TypeScript into JavaScript. And then what you want to do is you want to have several steps, right? The first step is to compile TypeScript to JavaScript, and then you want to run Karma. So here in this code line here, basically, what we're doing here is basically we're saying, hey, just here is the path, and okay, this is weird. Okay, let's see here. Strange, not sure why this happens. But anyways, what's going on here is simply you specify the path, and then you type Karma start. That's how you start up Karma, right, from Node. So you do the same thing on the build server. That's all you do, as a command line in TeamCity, and the build server will then run up Karma, right? And what you want to do is please use the attribute TeamCity. You have to do that with Karma. But there is a really good tutorial on this in the web, so it shouldn't be hard. But this is how you do it in TeamCity as a build step. And then moving on, here is all my build steps, right? I have, in this case, I have like 4 different build steps. The first one runs up, let's see, compiles TypeScript to JavaScript, and then runs Karma, and then we have code coverage. That's the step where code coverage is used. So set up code coverage. For TeamCity, you have ncover. You've probably heard about that. You can use ncover. That's what you should use. And all from that point on, everything is easy. It's documented on the web, how you should do it. And then it should be like this. Everything is censored here because this is actually right out of production. So I thought I'd show you here. So this is how it looks like in the real world. So you'd have a build step called JavaScript tests, just as simple as having your integration tests and your system integration tests. So just treat your front end as you treat your back end. Have these steps. And you could also have another step called coverage or something. JavaScript coverage. And then, yeah, this is how it looks like in TeamCity. You see all your tests up like this, and status on the left. And this is the name of the tests here. They're all running, and yeah, so it's pretty easy to do it. Just use the Karma-TeamCity plugin from Node, and that's how you do it. Okay, so now we have like 10 minutes for questions, and I know you've had a long day, but I'm really happy if you have any questions. Just fire away. Yeah. Okay. Yeah. Go ahead.
So, with the TypeScript code, can you still see the scopes in, say, Batarang?
So the question is, when you use TypeScript, can you use plugins like Batarang as you usually do when you work with Angular? The answer is yes, absolutely. You can do that. Because when you type TypeScript and with Angular, it gets compiled, right? But everything is there, the scope and everything, so that's not a problem at all. Yeah, and of course I also recommend source map. Because as you saw here, everything is compiled, right? And it looks really horrible. So use source map so you can map TypeScript with JavaScript, and then you can debug. Debugging is easier. Great, sure, I'm happy to have answered that. Any more questions? Yeah, go ahead. Not in this case. We didn't do that, but I would recommend it, absolutely. Use Grunt, and yeah, you could use Yeoman also if you want. So, yeah. So the question is dependency management. Do you mean dependency management? That's what I showed in the Bootstrapper part, or? Oh yes. So I think the question is when it comes to dependency. So when we're talking about require.js, for instance, right? If you have several files, and what do you do about that? Correct. What I would do is I would use require.js just as usual. So what you can do with TypeScript is you can write JavaScript also inside a TypeScript class. Okay, so this is fully possible. Yeah, just so you know. Yeah, sure. If you have a TypeScript class, you can type in JavaScript also there. So let's say you have this evil window object, right, in JavaScript. You can use this window object inside a TypeScript class. So that's not an issue at all. Any more questions? Go ahead.
Are you advocating that we should learn TypeScript to can you do without TypeScript?
So the question is, if you want to do TDD in JavaScript, do you need TypeScript for this? The answer is no, absolutely not. You don't need TypeScript to run TDD JavaScript. You can use let's say we have AngularJS application, we can use TDD there. That's not an issue at all. You just need to find out a way to get your injection working right properly. Because with Angular, we get this free. We get this like out of the box. It's really easy to do DI. So, and in this case here, I've used Angular mocks, which also comes with Angular, and to mock up my scope and this stuff. So as long as you have a good way of doing DI, dependency injection, then you can do it. And absolutely, you can do TDD with JavaScript. Yes, go ahead.
Or TypeScript starts to show importance. I mean, what is the like? Why did you move from writing Angular to like TypeScript, or why did you even come up with TypeScript and not pick up CoffeeScript? So are there?
Yeah. So that's an excellent question, actually, because as a programmer, the question was what motivated me to use TypeScript instead of, let's say, CoffeeScript, right? Now, when you work as a programmer, you should be pragmatic, right? So we are a .NET team. We're working in a huge .NET project. Now, TypeScript is a really, let's say it's an obvious choice to use because TypeScript is also now a first-class citizen of Visual Studio. So you get it with Visual Studio, and there's really good support for TypeScript in Visual Studio. So you always work with tools that are that really help you in the context that you are in. So that was our main motivation. Yeah. Yeah. Any more questions? Yeah, go ahead.
You use WebStorm. Why not Visual Studio?
Excellent question. For the customer that I worked at, there they just use Visual Studio, so we used Visual Studio there. But for me, in this case, I would prefer WebStorm because it's a really good IDE for front-end development. And we are at a front-end conference here. So it's a really good choice if you want to work with front-end only code. If you want to work with full stack, front-end and back-end, then I don't think I would recommend WebStorm because let's say I'm thinking from a .NET perspective, I want to work with C# code, then the obvious choice is Visual Studio, right? I wouldn't use WebStorm to write C# code and front-end code. That's just silly. So in this case, I only had to work with front-end code, and therefore I chose WebStorm. It's only front-end. And if you want to work with front-end, then I would choose something that fits the best way, the best way of typing. And with WebStorm, you get things like refactoring of JavaScript code, and that's really easy to do there. So yeah, it's a really good IDE for front-end. Yeah. And also, TypeScript. No, it's an external module that you have to download from npm when it comes to WebStorm. So, but I think you get it now out of the box. latest version of WebStorm will get TypeScript out of the box, I believe.
I seem to be using a lot of Sublime.
Sublime. Yeah, it's a bit, yeah, it's like, it's a bit hardcore, I think. I need something that's easy to work with and really efficient. And I find WebStorm is nice because refactoring, and I don't know, can you do refactoring in Sublime? It seems really, it's just a text editor. It's not even, yeah. Exactly. So, yeah. Actually, there was someone who said once that if you want a random generated string, just put a developer working with Vim and make him exit the program. He'll generate a really random string. Yeah. Yes. So, any more questions? Okay, then that's it. Thank you very much. I hope you had a good day.